We've learned the power rule and the product and quotient rule. Now we're going to learn derivatives of trig functions. Okay, and we have all of them here. Now we're going to start with a couple of limits that's sometimes called special trig limits, and later on, for us it would be in Cal 2, you learn something called L'Hopital's rule, and you could actually find these limits with L'Hopital's rule without having to memorize anything. All right, but for now, usually in Cal 1 they present these, and you just kind of have to remember the limit as x approaches 0 of sine of x over x is 1. The limit as x approaches 0 of cosine x minus 1 over x is equal to 0. Okay, and so the first couple of problems in the homework will have to do with those limits. So let's do that before we start doing derivatives of these. So I'm going to go back over here and do a few problems using those two limits. Okay, and one thing real quick back over here, sorry, to notice, just notice that for this limit x, these two angles are the same. Okay, one's x and the other one's x. It doesn't matter if it's 2x and 2x or 5x and 5x. It's still going to, the limit's still going to be the same. So as long as the angle on the top's the same as the x on the bottom, then it holds what it says there. All right, let's look at these two here. Okay. Now again, notice you've got sine 5x on the top, but you got 3x on the bottom. Okay. So the only time that you can use that and know what the limit is if you had a 5x on the bottom. So all you got to do is just manipulate it to where you have a 5x on the bottom. Okay. So what can I multiply 3 by to get 5? So I'm going to multiply 3 times something to get 5. What would that be? Well, okay, what about this? Will that work? 3's a cancel, and then you get 5, right? So if I want to change 3 to 5, I just multiply by 5/3. So let's take this and let's multiply the top and the bottom, because you always do this. If you always multiply the top and bottom by the same thing, you get an equivalent fraction, right? So I'm going to multiply 5/3 over 5/3, okay? So that will give me the limit as x approaches 0 of 5/3 times sine 5x over 5x, okay? And the way I get this, 5/3 times the bottom, the 3's cancel, that gives me the 5x. If I say 5/3 times the top, then I've just got that fraction over the bottom, and that's just the same thing as multiplying by the fraction. Okay? Any questions about that? Now, you can either move that 5/3 out in front, or you can leave it. It doesn't matter, because now I've got the sine of the same angle over itself. So what is that limit equal to then? That one is equal to 1. So I have 5/3 times 1. That limit would be 5/3. Okay? All right, this one, same thing. We got sine 7x, sine 3x on the bottom this time. We're still wanting to use that same idea. Sine of x over x, limit as x approaches 0 is 1. Okay? So what could I do with that?
Could you cancel the signs?
Can't do that. All right. So just remember, this is all one thing together. Sine 7x, sine 3x. So you can't do any, and you can't cancel the 7 and x and 3x out.
For these though, isn't it always going to be like for this one it'll be 7/3, but
Okay.
won't it always be that way for the you have sine or sine?
That would take care if it was 3x on the bottom, it would be. But this is sine of 3x on the bottom.
Oh.
Yeah, so yeah, if it was just 3x like the other one, it would be. Okay, but so this is a little different because you got that sine of 3x on the bottom. Any other ideas? Well, you want 7x on the bottom here and 3x on the bottom here, right? So first thing you could do, because you got to do the same thing to the top and the bottom. So the first thing you do is divide the top and bottom by x. So let's do that, and then we get this. Okay, so that's what you do that first, okay? Getting closer, okay? Now I need to get a 7 here, and I need to get a 3 there. And as long as I do the same thing the top and bottom, I'm good. All right? So, in order to get 7 down here, I need to multiply by what on the top and the bottom? One-seventh? 1/7. So let's say sine 7x over 7x, and then I would have a 1/7 on the bottom. Okay. Now I need a 3 here with this x in order to use the limit, right? So now let's multiply the top and bottom by what? 1/3, right? That would put a 3 right there. Now that would put me up times 1/3 on the top. Okay? What is 1/3 divided by 1/7? That's back to middle school also. Dividing fractions, multiply, flip the second one or the bottom one. 1/3 divided by 1/7 is like multiplying a third times 7. 7/3. All right. So now we will have 7/3. The limit as x approaches 0 of sine of x over 7x over sine 3x over 3x. Okay. And remember, with limits are not derivatives. With limits, you can just take the limit of the top divided by the limit of the bottom, and you're good. No quotient rule or anything. So the limit of that would be 1. The limit of that would be 1 7/3. Okay. Now this got tangent. Okay. What is tangent equal to? Sine over cosine. All right. So let's change that to the limit as x approaches 0 of sine 3x over sine 4x divided by cosine 4x. Okay, so I would do that. All right, and now if I'm dividing fractions here, right? So if I multiply and flip the bottom, I get the limit as x approaches 0 of sine 3x times cosine 4x over sine 4x. Okay. Now again, with limits, remember, yes, we're dividing, yes, we're multiplying, but you can just take the limit of everything separately and multiply and divide, and it's fine. So no quotient rules or any of that. So this is the same thing we had in the last problem, pretty much. Same type situation. So what you could do is rewrite it like we did in the last one. So you would have sine 3x over 3x with a 3 there, and then 4 sine 4x over 4x. All right. And then times cosine 4x. Okay. All right. So this will be then, you got a 3 and a 4 there you can bring out in the front. And then just take the limit of all of this. All right, so let me write it one more time. Limit as x approaches 0. So I get sine 3x over 3x times cosine 4x, sine 4x over 4x. All right, so I have 3/4 times. All right, what is the limit as x approaches 0 of these two here? 1. So I've got 1 times something over 1. The limit as x approaches 0 of the cosine of 4 times 0, which is 0. Well, if you remember your unit circle there, this point right there is 1, 0. What would the cosine be there at 0? 1, the x coordinate. So cosine is also 1, 3/4. Okay. Now, may throw you a curve. Okay, so I wouldn't think it's always the two numbers there. Okay. Can't ever tell. All right, any questions about that? Now, the limit is that we've got, the special trig limit is the limit as x approaches 0 of cosine x minus 1 over x, not cosine squared. Okay, so we have to do a little work here. Now, there's a couple of different ways you could manipulate that and figure out the limit. Any idea something we might could do? Okay. Okay, cosine squared plus sine squared equals 1. So what would cosine squared minus 1 equal? All right, well, if you took cosine minus 1, it would actually be what? You have to move that over here. So it actually be negative sine theta, right? So cosine squared theta minus 1 is negative sine squared theta, right? And that's the first way that I did it. I think that would be fine. So we'll have negative sine squared theta over theta. Okay. Now remember, with limits, again, you can multiply two things and it's fine. So I would just do this. Do the limit as theta approaches 0 of negative sine squared theta, or sine theta, times sine theta over theta, like that. Follow that? Now, what is the limit as theta approaches 0 of sine theta over theta? That one's 1. What is the limit as for the other one there? Well, again, here's your unit circle. That point's 1, 0. What is the sine at that angle 0 there? The y coordinate, 0. So that would be 0. 0 times 1, 0. So that limit is 0. Okay. Any questions about that? So, and all those are introduced in this one section. You got to remember those. Okay. I will never give you those on a test, I don't think. You've got to remember those 6. Right? So, again, when you get past Cal 1, it's more just the problems, because they're hard enough as it is after you get past this. But there's things you got to remember. And those are things that you really need to remember all the time, because you work a lot faster when you do. So, real quick, the first two it gives us here, and it does show us graphs. I do want to kind of look at this a bit. So notice the first one here. This is the graph of f of x equals sine x. So that's your sine wave. You cross is at pi, at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, right? Okay? So so this would be like the graph of its derivative. Okay? So notice you have a horizontal tangent right here. when x is pi over 2. You have a horizontal tangent there when x is 3 pi over 2. All right? So at those values, on the other one, that's where it should be crossing the x-axis. Because if this is the graph of the derivative is 0 at those points. So it's crossing at pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. Okay? Notice here, from 0 to pi over 2, is the slope positive or negative? Positive. And then as it gets closer and closer to 0, what's happening to it? It's getting smaller and smaller. Okay? So notice here, from 0 to pi over 2, your y value is positive, but it's getting smaller and smaller and smaller as it approaches 0. When you get here and you start going this way, what's happening to your slope? The slope is negative, right? And it keeps getting steeper and steeper until it gets to here, all right, where it's 0. So notice here, it's negative from here until there, then it's 0, then it starts being positive again. Okay, so if you go down here, you're going to have a positive slope, so on and so forth. So what happens with the graph? Well, that is the graph of what? The cosine wave. All right? The derivative of sine is cosine. All right? Derivative of e to the x is e to the x. Derivative of sine is cosine. Questions about that? Okay? You do the same thing with cosine. Okay? Your zeros, where it's horizontal, is at 0, pi, 2 pi, so on and so forth. All right? So that's going to be where it crosses the x-axis. Notice here, cosine normally goes through the point 0, 1. As you start, your slope is negative. So that means your slope will be below here till it gets right here, and then it's going to change from negative to positive. And then go. So this is what you get. What is this graph? That is the sine graph reflected about the x-axis. Okay? So the derivative of sine is cosine. The derivative of cosine is negative sine. Okay? Now, the others, they just give you, I think there's a problem later where you have those. So here they are. Okay? Now, how to remember them? Okay? Well, sine goes with cosine, tangent goes with secant, cosecant and secant go together. That's usually kind of how it works, okay? If the function starts with a c, cosine, cotangent, cosecant, the derivative is always negative. If it does not start with a c, it's positive, okay? So sine, tangent, secant, the derivatives are positive. Cosecant, cotangent, cosecant, your derivatives are negative, okay? If the negative is not there, it's wrong, okay? So got to remember which one is which. Sine, derivative is cosine. Cosine, the derivative is negative sine. Okay? If it is tangent or cotangent, you just got to remember, for tangent, the derivative is secant squared. Cotangent, it is negative cosecant squared. Okay? If you have secant and cosecant, secant, the derivative is secant times tangent. Cosecant, it is negative cosecant times cotangent. Okay? Again, it's one of those things you got to remember. Okay? It's not that hard to remember it though. Okay? So, but just get in the habit of that. You don't, I mean, at first you might need to look it up, but you don't want to have to look it up every time you want to do a problem. It's just will slow you down tremendously. So, there they are. All right, so any questions? All right, let's do some problems. We've got 10 minutes. Okay, so I've got y equals e to the negative x times sine x. Okay, I want to find the derivative. Okay. Well, first, I don't know how to take the derivative of e to the negative x yet. Now, we will really soon, but we don't know how to do that yet. So, what should I do to make that where I can do the derivative? I need it to be e to the x, right? Just move it to the bottom. So, this will be y equals sine x over e to the x, okay? Now, to find the derivative, I need to use what rule for that one? Quotient, because you got a quotient. You got a function of x divided by a function of x. So y prime equals, all right, so I start with the bottom. Bottom times derivative of the top, so e to the x times the derivative of sine. What is the derivative of sine? Cosine. Minus the top times derivative of the bottom. What is the derivative of e to the x? E to the x over the bottom squared. Okay. Questions about that? All right, so the top, factor out an e to the x. So I get that. So then e over 2x, and then I've got e to the x on the top, e to the 2x on the bottom, so you can divide those, and that would just leave an e to the x on the bottom, right? So your answer would be cosine x minus sine x over e to the x. All right, questions about that? All right, got a quotient, right? Quotient rule. So y prime is equal to, all right, the bottom times derivative of the top. So sine x plus 1 times, all right, what is the derivative of cosine x? It is negative sine x, right? Starts with a C, derivative is negative. So negative sine x minus the top times derivative of the bottom. So derivative of 1 is 0. What's derivative of sine x? Cosine x. Positive cosine x. All right? Over the bottom squared. All right, multiply the top out. So I will have negative sine squared x minus sine x minus cosine squared x over sine x plus 1 squared. Now we've got to reduce these things, okay? Now one thing when we're dealing with trig functions that you want to watch for is anytime you have a Pythagorean identity, okay? So remember the Pythagorean identities, one with sine and cosine is sine squared plus cosine squared equals 1, right? I have that right here, okay? It's negative since the signs are the same, all right? So what you could do is take those two and factor out a negative, and that gives you this. So I'll write it out for you. Okay, and then what is sine squared plus cosine squared? 1. So I get negative, let's write negative sine x minus 1 over sine x plus 1 squared. Okay, and now the top, I could factor a negative 1 out of the top, right? That would be helpful because then if I do that, I'll have a negative. I have sine x plus 1 over sine x plus 1 squared. It's helpful now because now I have the same thing. I have sine x plus 1 and then sine x plus 1 squared. So I can cancel this sine x plus 1 on the top out with one of these on the bottom. So I will get negative 1 over sine x plus 1 as the derivative. Okay, any questions about that? All right, so I want to do the derivative. So I have a product. Got to do the product rule, okay? So y prime equals, all right, so I'm going to have the first times derivative of the second. In whatever order you want to start on it is fine, but let's do that on this one. All right, so first times derivative of the second. What is the derivative of cosine? Almost. Negative sine, right? So if it's a C, it's a negative. So negative sine plus the derivative of the first. What's derivative of sine? Positive cosine times cosine, okay? So now that if I reduce that, that gives me cosine squared minus sine squared. Now I'm okay with that answer, but you're doing your homework. If my math lab does not take that, okay, that actually matches a formula, a trig formula, all right? And you can look that one up. If you look on the trig page I gave you, that should be a double angle formula. So that should be a that is the same thing as cosine of 2x. I think you have 3 different formulas on there for cosine 2x, and that's one of them. So, like I said, I would be okay on a test with this, but when you're doing your homework, if you have something like this, you might need to use a formula to make it a little simpler. So, all right. Of course, the directions are to find the derivative. Okay. All right, so looking at the problem, what rule do I have to use as far as differentiation goes? Quotient. We have a quotient. So I've got his quotient rule, and then within that, what do I have on the top up here? I have a product there also, right? So just follow the rules. That's the main thing, all right? So if it's quotient rule, remember we start with the bottom. So the derivative of y would be the bottom times the derivative of the top. Okay, so again, to do the derivative of the top, I've got to use the product rule. Okay, so I'm going to say the first times the derivative of the second. Well, let's do it the other way. I'm going to say the derivative of the first times the second. Derivative of x is 1 times sine x plus the first times derivative of the second. So the derivative of sine is cosine. So x cosine x. Okay? So that is the bottom times derivative of the top. So now the top minus the top times the derivative of the bottom. Okay, so 1 plus cosine x, derivative of 1 is 0. Derivative of cosine, negative sine, right? So that would be times negative sine x over the bottom squared. Okay, any questions about that first step? Okay, now you just got to reduce. Okay, so always with this quotient rule, I would just leave the bottom squared like it is there, and then just kind of reduce the top and see what happens. So I'm going to leave the bottom 1 plus cosine x squared. All right, so on the top, I'm going to distribute this out. It's binomial times a binomial. So I would have 1 times sine x, and then 1 times x cosine x is x cosine x. And then plus cosine x sine x plus x cosine squared x. Okay. Now over here I've just got a single term times a single term. I've got a negative times a negative, so it'll be a plus. That'll be x sine squared x. Okay, any questions about that? Now to reduce this, a little bit of algebra here. First, notice anytime that you've got the trig functions that are squared, look for Pythagorean identity if it's possible to use that to reduce. Okay, and notice here if I take these two, those two, and I factor out an x, then I will get this. If I factor out an x, all right? Well, then I get cosine squared plus sine squared. What is cosine squared plus sine squared? 1. Pythagorean identity. So this thing here just equals 1. So I will just have then, so let me go up here, sine x plus x cosine x. I'm going to change this order real quick here. I don't have to write this again. I'm going to do sine x, I'm going to do cosine x, sine x. Then I'm going to do x, cosine x. And then all that's left here is just going to be x, because cosine squared plus sine squared is equal to 1. Okay? Questions about any of that? All right, now look and see if there's something else you can do to reduce. Okay, from this particular problem, if you notice how I've grouped them together, these two and these two, if I take the first two, I can factor a sine x out. So if I do that, I get this. Okay, right? If I take the second group, what can I factor out of this group? The x, and then I'll get cosine plus 1, which is the same thing as 1 plus cosine. So let's go ahead and just turn that around. Get that. So it's factoring by grouping is really what I'm doing on the top. So now I can factor out the 1 plus cosine x from this term and this term, and that will reduce then to be, or factor to be this. Okay, questions about that? Now, there's multiplication there. I've got one factor of 1 plus cosine x. Here I've got two factors of 1 plus cosine x. So that 1 on the top can divide out with one of these on the bottom. So my reduced answer would be sine x plus x over 1 plus cosine x. So that would be a reduced answer, the derivative. Okay? Okay, so what do I have here to start with? What operation's going on here? Multiplication. How many things am I multiplying? 3 things, if just the way it is right there, right? So it's x is a function of x, cosine x is a function of x, sine x is a function of x. So I'm multiplying 3 things. On the product rule, how many functions of x do I have on the product rule? I just have 2, a first and a second, right? So just group them together however you want to, where you got 2 functions of x, and then follow the product rule. So I think I put x just with cosine x and grouped them that way. But you could do x and then group cosine and sine together if you wanted to. Might be easier, I don't know. But I grouped them together like this. Okay, and now I'm just going to follow the product rule. So I'm going to I'll say y prime is equal. Okay, so I did the first times derivative of the second. So x cosine x times the derivative of the second, derivative of sine, is cosine x, and plus the second times derivative of the first. So now so I've got sine x. When I multiply that times the derivative of the first, I am multiplying by a product, right? So I got to use the product rule again to take the derivative of x cosine x. Okay? So to get the derivative of this, I'll say the first times derivative of the second. So derivative of cosine is negative sine. So negative x sine x plus the second times derivative of the first. Derivative of x is 1, so that would be cosine x. Okay. All right, here we go. So now we're going to reduce. So x cosine squared x. Here I would have minus x sine squared x plus sine x cosine x. Okay. Now I have this cosine squared sine x stuff going on here, right? But what operation is between them? Minus, not plus. If that was a plus, then I could factor out of x and say cosine squared plus sine squared is 1. Okay, but I don't have that. So, but if I do factor an x out of the first one, anytime you've got cosine squared x minus sine squared x, There is a trig identity that will reduce that and make it simpler. Okay? Anybody know what that is? I know you're writing all this down. If you do look at your trig sheet, okay, and double angle formulas, there's a double angle formula for cosine squared minus sine squared, and it is cosine 2x. So cosine squared minus sine squared is cosine 2x. There's actually 3 formulas for cosine 2x, and that's one of them. So that will be, I can make that simpler by making that x cosine 2x, and let's see, plus, and then sine x plus cosine x is also, there's a double angle formula for that, which is sine 2x. All right, and that one, there's just one for that, one double angle formula for that one. And for sine 2x is sine x cosine x. So just look on your trig sheet for that, and those are not, you don't necessarily have to remember those. They probably would pop up from time to time, so it'd be easier if you could, but if you don't, it's no big deal. But look, you can look them up if you need to. All right, so quotient, right? So I need to do the quotient rule. When I do the quotient rule, I always start with the bottom, right? So the bottom times derivative of the top. So e to the x times the derivative of sine x plus cosine x. So derivative of sine is cosine. The derivative of cosine is negative sine, right? So minus sine x. Okay, so that's the bottom times derivative of the top minus the top sine x plus cosine x times derivative of the bottom. What is the derivative of e to the x? E to the x. Over the bottom squared. So if I square e to the x, I'll go ahead and write it out. I just say x times 2 there, right? Multiply the exponents. Okay. This should just take just a little bit of reducing, I think. All right, so let's FOIL out or multiply out the top here. So e to the x cosine x minus e to the x sine x. Okay, now notice here, I really just got negative e to the x times each of those. So that would be negative e to the x sine x, negative e to the x cosine x over e to the 2x. Okay. Now notice I've got e to the cosine x, e to the x times cosine x minus e to the x times cosine x. So those will subtract off. And then I will have negative 2 e to the x sine x over e to the 2x. Okay. And now all of this on the top is multiplication. So since it is, I've got e to the x as a factor on the top, e to the 2x as a factor on the bottom. So this bottom is like e to the x times e to the x. So that 1 on the top can cancel with 1 on the bottom. So we'll end up with negative 2 sine x over e to the x as the derivative. All right, so I have a product, so I've got to use the product rule. All right, so y prime equals first times derivative of the second. All right, so secant x times, what is the derivative of a tangent? If you forgot it already, secant squared, all right, plus the second, which is tangent, times derivative of the first. What's derivative of secant? Secant times tangent. All right, so that will give me secant cubed x plus tangent squared x secant x. And that answer is probably fine. Sometimes my math lab might want it in a factored form, I don't know, but you can factor a secant out. And there's really nothing else that's going to reduce this. You can write it differently, but not necessarily reduce. Secant squared times tangent squared is not 1. So, all right, so we have a quotient So we need to use the quotient rule. So I will take the bottom times derivative of the top. All right, so derivative of tangent secant squared, right? Minus the top times derivative of the bottom. So the derivative of 1 is 0 plus derivative of secant is secant times tangent. Over the bottom squared. Okay. All right, so I guess let's multiply that out on the top. So we would get secant squared t is that necessary? Let's see. Yeah, okay, we'll go ahead and do that. All right, so minus secant t tangent squared t over 1 plus secant t squared, okay? All right, so now that we've multiplied it out, the parentheses there, now notice there is a secant that is in all of those. If we take that out, we get this secant plus secant squared t minus tangent squared t over 1 plus secant t squared, okay? All right, so secant squared minus tangent squared. Okay. Secant squared is equal to tangent squared plus 1. That's the form of the Pythagorean identity with secant squared and tangent squared. So what would secant squared minus tangent squared equal? It'll equal 1. Okay. So again, you need to remember the 3 trig Pythagorean identities, right? So this one wasn't helpful. It wasn't really helpful with this, so we left that one alone. This one, though, I can make that 1. So I would have secant t times, I'm going to write 1 plus secant t over 1 plus secant t squared. Okay, and now what do you notice we can do? Well, we got one factor of 1 plus secant t on the top. We got 2 factors of 1 plus secant t on the bottom. So 1 on the top, we can divide out with 1 on the bottom. So I get secant t over 1 plus secant t. Questions about that? All right, one more of these, and then we'll move on. Another Pythagorean identity is cosecant squared theta is equal to cotangent squared theta plus 1. All right, so what is cosecant squared minus 1 equal to? Cotangent squared. So we don't know what to do with cosecant squared yet. Now we will after we do chain rule, not in the section after the next one. So, but what we could do with this is rewrite it. So cosecant squared minus 1 is cotangent, and since I've got it written as cotangent squared, then now I can say, all right, that's the same thing as y equals cotangent times cotangent, right? And I do know how to take the derivative of a product. Okay, so this will be first times derivative of the second. So cotangent theta, the derivative of cotangent is what? Negative cosecant squared, yes. Plus the second times derivative of the first, which is going to be the same thing. All right, just put those together. This will be negative 2 cotangent theta cosecant squared theta. All right, so any questions about that? There's a couple of problems here that say verify the following derivative formulas using the quotient rule. Okay, so we just memorized them, right? We memorized that derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant times cotangent. All right, but we can verify that by using the quotient rule. So let's do, I won't do cotangent, let's do cosecant. All right, well, if I use the quotient rule, how can I write cosecant? What's another way of writing cosecant? So cosecant is the reciprocal of what? Sine, right? Now sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent, cotangent are reciprocals. So I could rewrite this as 1 over sine x, okay? So now if I wanted to use the quotient rule here, then I would say the bottom times derivative of the top. The derivative of 1 would be what? 0. So sine x times 0, bottom times derivative of the top, minus the top times derivative of the bottom. Derivative of sine is cosine x over the bottom squared. Okay? So I've got negative cosine x over sine squared x, all right? So now if I just, since I've got cosine over sine squared, I can rewrite that as 1 over sine x times cosine x over sine x, right? Okay? What is 1 over sine x? Cosecant, right? Cosine over sine, what is that? Cotangent. So I've got the derivative of cosecant to be negative cosine times cotangent, okay? Just by using the quotient rule. All right, any questions about that? So we still had to know the derivative of sine, but we could get the others there. It's better if you memorize them, though. You don't want to do that every time to figure out the other one. So, all right. Next, just a couple of problems where it says find the second derivative. Okay, so let's do a couple of these. All right. So I've got a product. Okay, so I got to do the product rule. So I got to find the first derivative, and then when I take the derivative of the first derivative, that gives me the second. So the first derivative, I would take the first times derivative of the second. Okay, plus the second times derivative of the first. Well, the derivative of e to the x is e to the x, so I get e to the x sine x. Okay, that's my first derivative. You could factor an e to the x out. It might be easier to do that way. Let's do it that way. So let's factor out an e to the x. All right, so now I've got one single product to do. All right, so the second derivative, I take the first times derivative of the second. So derivative of cosine is negative sine. Derivative of sine is cosine. Plus the second times derivative of the first. Derivative of e to the x is e to the x. Okay. Now let's distribute this out. So I would have negative e to the x sine x plus e to the x cosine x plus e to the x cosine x plus e to the x sine x. Okay. So notice the negative e to the x sine x and the plus e to the x sine x, those subtract off. So I'm left with just 2 e to the x cosine x for the second derivative. We're starting out with a product. All right, so I'm going to take the first times derivative of the second. So secant x equals, or times, the derivative of cosecant would be negative cosecant cotangent, all right, plus the second, first times derivative of the second, second times derivative of the first, which would be secant tangent. Okay? All right, now this looks like a mess here, doesn't it? All right, so we've got a lot going on. So one thing that I did at this point was tried to kind of put these together. Cotangent is cosine over sine, right? And tangent is sine over cosine, and then this is 1 over sine and 1 over cosine. So if we kind of think of those in terms of sine and cosine, this is what you have. All right, so secant is 1 over cosine. Cosecant is 1 over sine. And then cotangent is cosine over sine. All right, plus cosecant is 1 over sine. Secant is 1 over cosine. Tangent is sine over cosine. Okay. So now by doing that, notice sine cancels. Cosine cancels here. So I end up with 1 over cosine squared x minus 1 over sine squared x, which is secant squared x minus cosecant squared x. Okay. Now again, we don't know how to do that with the chain rule yet. We will. We'll learn that really soon. So what we would have to do then is write it as secant times secant minus cosecant times cosecant. Okay, and then just do the products again. Okay. Second derivative. All right, so first times derivative of the second. Plus the second times derivative of the first. Minus, all right, so I'm going to do parentheses here. So this would be the first times derivative of the second. So cosecant x times negative cosecant cotangent x plus, again, same thing, cosecant x negative cosecant x cotangent x. Okay? This will reduce a little bit here. All right, so let's see. 2 secant squared x tangent x. And then here I've got minus a negative and minus a negative, so plus 2 cosecant squared cotangent. That's my answer. All right, so not a big deal with reducing there. So 2 secant squared x tangent x plus 2 cosecant squared x cotangent x. Second derivative. All right, any questions? Okay. All right, we'll do one problem where it says find an equation of the line tangent to the following curve at the given value of x and use a graphing utility to plot the curve and the tangent. All right, so let's say we've got this one. And we want to know the line tangent to the graph when x is pi over 3. Okay? So to do the tangent line, we need a point, which we definitely can get from pi over 3, and we need the slope of the tangent line. Slope of the tangent line comes from the derivative function, right? So we've got to find the derivative. All right, so let's do that first. All right, so I'm just going to put 4 here with sine. All right, so the first times derivative of the second plus the second times derivative of the first. Okay, so I get 4 cosine squared x minus 4 sine squared x as the derivative. Okay. All right, so first I need to know what my point is. So in order to do the slope of the tangent of the equation of the tangent line, I've got to have slope and I got to have a point. Okay. So to get the slope, let's plug pi over 3 into the derivative. Okay. So if I put pi over 3 into the derivative, I've got to do 4 times the cosine of pi over 3 squared minus 4 times the sine of pi over 3 squared. Okay? Now, what is the cosine of pi over 3? Okay, goes back to your quizzes, right? So if you've got pi over 3 is going to be right here, right? What is that point that goes right there on the unit circle? What's the point?
Is that the square root of 2?
Okay, that would be pi over 4. This is pi over 3. All right. The one toward the inside is 1/2 and root 3 over 2. Okay. So the cosine is the x, so that's going to be 1/2. Sine would be the y, root 3 over 2. So this will be 4, 1/2 squared. 1/2 times 1/2 is a 4th. All right, root 3 over 2. If I square root 3, I get 3. If I square 2, I get 4. 4 times a 4th is 1. 4 times 3/4 is 3. So 1 minus 3 is -2. So my slope of the tangent line should be -2. Okay. To find my x1, y1, I go back to the original function and I plug pi over 3 into it. Okay, so again, sine is root 3 over 2. Cosine is 1/2. So the 4's cancel there. I just get root 3 for the y coordinate. So the point on the graph of the function where I'm looking for the tangent line is pi over 3 root 3. Questions about any of that? So I have y minus y coordinates root 3 equals -2. The slope x minus the x coordinate is pi over 3. All I can do there really is just -2x plus 2 pi over 3 plus root 3. Okay. Last thing on this section. Look over at, back over here. Let me see if I can make this where we can see it all. All right, so we've got 4 graphs at the top and that are functions, and then we've got 4 graphs of derivatives on the bottom. Okay? So if we want to take each of those and try to figure out which of these matches it, okay? So if you look at the first one there, okay, so just look at that graph, pretend like this is a quiz, all right? What is that, what is that the graph of? That's the graph of tangent, okay? What is the derivative of tangent? Secant squared, okay? So the secant graph, normally, the secant is the reciprocal of cosine. So if you look at this one right here, normally it would go right with the cosine graph, right? What would the square do on the derivative? It would make all those negative y's positive, which flips it up where you got all the u's going up. This would be the graph of secant squared. Now, if you look at the way it works, the way it's going here, so like if you start with negative 2 pi, all right, that slope as it goes up that way is positive, right? And it's getting steeper as it goes up, okay? So notice here, from negative 2 pi to the asymptote here, what's happening to the slope? It's going up and it gets steeper, steeper, steeper. Okay. When we get to here, we have a really steep slope, and then it starts going in, right? Until it's this way. What's the slope whenever it's this way on the x-axis? 0. And then it's going to be, positive again. So it's like your slope is getting less and less until it's 0. And then it starts going positive again, increasing again after that. They're all positive slopes. But as far as the y value here, the slope is decreasing until it's 0, and then it starts increasing again as it goes on. And that gives you those u's there that you get. Any questions about that? Do you see that? Look at it, when you get a chance. And, if you don't, and maybe it'll make sense. B, what's B the graph of there? What function is B? Cotangent. Derivative of cotangent is negative cosecant squared, right? So that means they're all negative, which is this one, right? So your u's are all going down. And the same thing should make sense as far as the slopes when you're comparing the two. What is this one? Is that secant or cosecant? Secant. That is secant. All right, because it goes along with the cosine one, right? So secant, derivative of secant is what? Derivative of secant is secant times tangent, okay? I don't know which of those graphs would be that. So let's, your asymptote should match, so it should be this one. But if you, right here at 2 pi, your slope should be 0, right? And then you're going up like this, so it's getting sharper and sharper growing. So what's happening here? Here your slope is positive, but to get here, then it's 0. So that's going to be from here to here. And then when you get this way, the slope is doing what? Negative, right? Which is going to be below the x-axis. Does that make sense? Okay. And then the same thing with this one, which would be cosecant, and that one to match. Okay. Derivatives of trig functions. Any questions about those? Okay. All right. It's all of 3-5.